Gravity is a inward trajectory from the He-BEC singularity down from 4e to the negative 14 of the meter down to 1.6e to the negative 35 of the meter. So that's a distance of 4e to the negative 22 meters. The square root of that is 2e to the negative 11. So that's getting very close to the 6.67 e to the negative 11 of gravity. And if we consider the speed at which light is traveling inward, so that square root of the velocity of the alpha particle outward, the inward trajectory is 54,686 meters per second, including 1 over alpha of 137.036, we get a particular number when added to 1 over c, which is 17,314 plus 1 over alpha. When we add all those numbers together, we get 72,000. Why is that important? Well, if we consider the expansion rate of the universe as around 72,000 meters per second per megaparsec, so that's the Hubble constant based on the SUSY inversion model, inverse square law relationship. So the gluon field and the gluon force has some really interesting properties. It gets stronger the further apart the quarks get. And if you consider the problem at the moment in quantum mechanics not being able to integrate gravity down at the singularity, here's an approach that I've taken based on inverting gravity and inverting Ke, which is the force of the electric charge. So if we see what the inverse of Ke is, 1 over force, then we can get a linear relationship. And that's also seen in gravity, right? We've got this 1 over gravitational, or the gluon force, and 2e to the plus 70x. That's a really interesting number, and that correlates to a kind of quantum background calculation of energy in terms of the Planck length, 1.6 e to the negative 35 of the meter, and the inverse of that of 6.25 e to the 34 meters. You divide one by the other and you'll get a very similar number. You get an e to the negative 69 or e to the negative 70. So we've got mirrored symmetry happening through the inverse of the inward trajectory. And when we combine Coulombs with gravity in this graph here to the left, you can see that the radius distance, as you get further and further apart, the force is increasing. So the gluon force increases with respect to an inversion of Coulombs and an inversion of gravity. So gravity down at the singularity is an inward trajectory. It gets stronger and stronger the closer it is to the singularity. And I guess the relationship of inverting G and inverting the Ke provides a way of understanding the gluon force within the meson sphere. It is an approach that I've taken based on inverse square law. It's a deterministic approach. It provides a rational way of understanding why, as the quarks get closer, they get weaker. The force between them gets weaker, and as they get further apart, they're getting stronger. So this is the inverse square law. Down at the singularity, it's not a quantum mechanical approach. I've done away with quantum mechanics because I wanted a deterministic model that was able to predict outcomes. By understanding the singularity state of the 0-point energy field, where everything's in balance, there is no space, no time, no mass, no charge, because every action cancels out every other reaction, and so this balance of opposite states really provides context of why the singularity at the beginning of time, where all the electrons are at that ground state, has no mass, no charge, no space, no time, despite it being a superatom really, really large, as a Bose-Einstein condensate of helium.